Suresh Kumar, he has given the lecture yesterday. He's also joined. He's the Chief Engineer, Creation Department. So,
very nice.
Good afternoon. Yeah. Okay. So, good afternoon to all. Welcome all of you to the 5th day of our lecture series, and this is the final one. We have today with us my old friend Dr. V. Ramachandra, who is the Principal Advisor Tech Services. He's with Ultratech Cement Limited, Mumbai. In fact, it's at different locations, different the programs we were together, and he had a good interaction with NIT Trichy, and we arranged so many programs because he is an expert in the rigid pavement, concrete pavement, then thin white topping, etc. So he is a graduate in BE Civil Engineering, MTech in Marine Structures, and PhD in Structural Engineering. He was a professor of civil engineering at SIT Tumkur for 20 years till 2005. From 2005, for about 17 years, he was with Ultratech Cements at the capacity of South Zone Tech Head for 11 years at Bangalore, and joint President and Head Tech at Bombay since 2016. And some initiatives for the construction industry. He is technology demonstration project on white topping in Bangalore, Chennai, Hyderabad, and Kharagpur. Very successful projects, and taken it as a model to other cities. Alternative technologies for mass housing projects, development of new cements and building products as part of our the Ultratech Cement Limited. Professional way, former Vice President of Indian Concrete Institute, member Academic Council in Autonomous Institutions Bar Universities, member of Board of Studies Civil Engineering in various universities and institutions. Was participated as the invited speaker at Kumamoto University, Japan in 2013. Was the member of Indian BAS delegation to ISO to Japan and USA in 2017 and 2019 respectively. He was attended construction industry visits to Russia, Europe, Indonesia, and Australia. Currently, he is a member of S3 Rigid Payment Committee, Indian Road Congress, New Delhi. Member Civil Engineering Division Council, Bureau of Indian Standards, BIS, New Delhi. Member Research Council of Central Building Research Institute, CBRI, Roorkee. And a member Technical Committee, Cement Manufacturers Association, New Delhi. Thank you, Ramachandra sir, for accepting our invitation at a very short notice. And I know that one you will not deny my invitation. And this is the first time to NATPAC and my scientists. In addition to that one, we invited people, our project fellows are also there. And we publicize that one through our net also. So maybe some people will be attending through online also. Welcome all of you to this session. And over to Ramachandra sir for the lecture.
Yeah. So very good afternoon, and first of all, my sincere thanks. It is very nice of you, Professor Samson Matthew, to have invited me, and whether it is in NATPAC or in IIT Trichy, I have always admired your contribution to the education as well as to the transportation engineering sector. Therefore, it is with a lot of respects and affection for you that I have agreed to be a part of this program. Now, this presentation is on distress-free rigid pavements. Now, the question of whether flexible pavements should be adopted or pavements or concrete pavements should be adopted is quite an old question which has already been answered. And today, with the cost of bitumen, the cost of petrol, diesel, and bitumen going up very high. In fact, you may not believe me if I say the cost of construction of 1 kilometer of concrete road, initial cost itself is, in fact, it is cheaper than the cost of construction of 1 kilometer of bitumen road. Earlier, we used to say that concrete roads are slightly expensive, but they are cheaper if you consider the life cycle cost. But now, even in terms of the initial cost, concrete roads have that cost advantage also, in addition to the other advantages of long life and less maintenance and so on. Now, one reason why concrete roads were not very popular was because, in case something goes, if there is some distress, then how quickly you can repair. Now, there are answers for this. Let me start my presentation right away. Yeah. So these are the contents. What are the current challenges we have, and comparison of performance and concerns and distress in concrete roads and solutions. These are the things that I want to deal with today. Now, whenever I think of concrete roads, I always remember this great man, Dr. L.R. Kadiyali, who brought me to this concrete roads thing. I would say he pulled me into this, and therefore I am forever I am indebted to him. He was the person who exposed me to the various aspects of construction of white topping as well as concrete roads. In my lecture today, I very respectfully acknowledge contributions from Dr. Binod Kumar of RRI and several IRC publications and discussions. As a committee member, I have gained a lot of things from them. And my team, team in Bangalore, Chennai, Jaipur, Hyderabad, and Kharagpur, they have always worked with me implementing these things. Now, coming to the concrete pavements, in fact, India has a very least share of concrete pavements. Japan has about 6% roads in Japan are concrete roads, whereas in US it is about 35%. And Korea has most of the roads, 63% of Korean roads are concrete roads. Compared to less than 5% concrete roads are there in India. And in these days, number of concrete roads are that is coming up are quite huge. It is not that concrete roads are new. Long back, if you consider the world affair, 1909 was the first concrete road that was made in Detroit, USA. And on the right-hand side, what you are seeing is a very, very interesting thing. This pavement with paver blocks, interlocking concrete paver blocks in USA was done in 1906. More than 110 years back it was done. But this photo is not 106 years back or 100 years back. This photo was taken hardly about 20 years back, which means even after 90 years of its construction, this road is giving fairly excellent service. As far as India is concerned, the first Indian manual on concrete roads, it published in the year 1939. And on the right-hand side, what you are seeing, 1960, the concrete road that was built in Matunga, 200 mm thick. There is no overlay even today. I repeat, even after 62 years, there is no overlay, and this is giving an excellent space even after 60 years. That is the life of concrete roads that you have. But currently, we have a lot of challenges as far as our roads are concerned. This is a very common scene, whichever city you are in. Don't look at the color of the bus and say that only Mumbai is bad and other cities are better. Wherever bituminous pavements are there, this is a problem that we are seeing. As per the 2017 statistics, pothole-related deaths, people died due to potholes, more than 3,500 people in India
Peter.
Sanjay?
Sir, I think some issues with Ramendra sir's net connection.
Okay, probably you can contact him and he can mute his video if it's okay.
Yeah.
Yeah, I think I have joined now.
Okay, sir. Okay, sir.
Yeah. My slide is visible now.
Sir, slide number 9.
I hope my slide is visible now.
Yes, sir. You are talking
Yeah,
about
yeah.
slide
Okay. I
number
think.
9.
Yeah. Now I'm talking of good roads, a fundamental right.
Right, sir.
Yes.
Yeah, no problem. Other things I have already explained, therefore there is no issue. In fact, Mumbai High Court, the year 2015, has said that right to good roads is a part of fundamental rights of Indian citizens. So it is also important that because this is recognized as a right to have a good road, it is imperative that we construct good roads. Now, this is the Marine Drive Road, which constructed in the year 1999 in Mumbai. It lived for more than 70 years, and in the year 2012, overlay was put after 73 years of its service. There are several such examples. Mumbai Expressway was constructed back, and in white topping, Pune has constructed a lot of roads. Even Bangalore and Chennai, there are quite a few roads which are made out of white topping. Now, as far as highways are concerned, Yamuna Expressway, 165 kilometers between Noida and Agra, this is constructed with blended the Portland Pozzolana cement, PPC cement. This is constructed M45 grade of concrete, 8-lane road, and you can see this road is not inferior to any roads that you see in any advanced countries. Now, when we think of the comparison between a bitumen road and concrete road, what makes a difference is that because concrete is a rigid material, the loads get distributed over a larger area, and therefore pressure on the layer below is always less. Now, in case of bitumen pavements, the loads get distributed to the layers below also, and therefore the pressure is normally higher. Therefore, one question that comes, I have just put as for a comparison, who damages the roads most? We are talking about the damages. Who damages the roads most? An elephant walking on the road, will it damage the road most? Or a beautiful lady like Aishwarya Rai walking on the roads, will she damage the roads worse than the elephant? This is a simple question. Anyway, the answer is quite obvious. Aishwarya Rai and elephant. I have assumed, I don't know, I have assumed that Aishwarya Rai weighs 60 kgs and she walks, she stands on shoes of pointed heels and toes. Therefore, 60 kg divided by 2 shoes and 2 points and 5 square centimeter per point, the pressure comes to 3 kg per square centimeter. Whereas in case of an elephant, it weighs 4,000 kg compared to Aishwarya Rai, and it stands on 4 legs, and pressure on that equal to 4,000 divided by 4 legs, 20 by 20 centimeters is the average area. The pressure is 2.5 kg per centimeter square. Therefore, it is not the load that is important, which is distributed over an area that causes pressure. That is much more important and causes damage to the roads. There are a few issues that I want to say before we go to the stress. One is concrete roads are very good from several points of view. From the cost comparison, it is better. From the sustainability point of view, it is better. Life is better. Maintenance is nil, and light reflection is better, and so on. So many good things are there, but there are a few. Number one, first issue is that when concrete roads are constructed, we cannot allow digging of concrete roads. Normally, whenever a road is constructed, after some time you will see some agency, whether it is water or power or sanitary services, to access their service lines, they dig, they cut open the roads. This is one thing that we should avoid. Avoiding digging of concrete roads is one issue they need to address. And second is, generally when you drive on a concrete road, the noise will be slightly higher compared to bitumen roads. Now, this noise can be reduced by going for longitudinal texturing than transverse texturing that we normally do. Longitudinal texturing, which is not a normal practice in India, that reduces noise. Now, how do we avoid, the first point is how do we avoid digging of concrete roads? It is possible to do that by placing trenches or transverse ducts so that concrete roads are not dug. So you can see in this, on the shoulders, you have the paver blocks that are there, so that you can access this, and road cutting is always avoided. Now this cross duct placed, let us say 50 meters interval, 50 or 75 meter interval, depending on the population of that area. And you can always access this through these cross ducts instead of digging this. Even on small roads, it can be done like this. Here you can see cross ducts that are present there, regular intervals, so that you can access whatever the service lanes that are there on that road. Maintaining quality in concrete road construction is always most important so that we avoid problems. Now, if there are problems, there are always solutions, but then it is better we avoid problems by going in for better quality in road construction. To understand this is always best understood by looking at the distress pattern or the failure pattern. Maybe the reasons could be the deficiency in the design, or the material, or the mix design, or construction that starts showing up in the form of cracks, structural failures, etc. But if the distress is noticed, correction techniques are always available. There are a lot of IR codes that are available for the design and construction and maintenance of concrete roads. In fact, IRC has been revising these codes quite regularly these days. In fact, some of these, the last one is IRC SP 83. It is not 2008, it was revised in 2018 again, guidelines for maintenance and rehabilitation of concrete, cement concrete pavements. Now, these are all the IRC guidelines that you have for construction of roads which need to be followed. And design guidelines, IRC 58 is always applicable for roads having commercial traffic over 450 CVPD. And for low volume traffic, you have the SE 62, which needs to be followed. Now, one or two basic things as far as PQC, pavement quality concrete, is concerned. Normally, the concrete flexural strength, concrete roads are designed for flexural strength. It should be about 40 to 45 kg per centimeter squared, or 4 to 4.5 MPa flexural strength. It should be there. If you use M35 or M40 concrete, you will be able to do this. Number two is about the slump. Now, as far as slump is concerned, normally it is specified in the specifications that it should be 55 mm or 50 mm slump. Now, I would say that the slump requirement, it depends on the method of paving. Whether we use the manual method of paving, or we use fixed form pavers or slip form pavers, the slump of concrete depends on the method of paving. There is no standard formula for slump. It always depends on the method of paving. Suppose we go in for manual concreting, which we used to do in the earlier days, the slump can be 40 to 50 mm. Whereas if we use fixed form paving, then concrete is in transit mixers, ready mix concrete, and it is poured. It has to be pumped. Therefore, for pumping, you require a minimum of 75 to 80 mm slump, or even 100 mm slump is used. Now, if it is less than that, it would become difficult for pumping concrete. Whereas if we make use of a slip form paver, what we need is a zero slump concrete. Concrete is not brought in transit mixers. They are brought in dumps, and it is just dumped onto the paver machine, and it is factored. Therefore, slump depends on the method of paving. As cement content is concerned, 450 kg per meter cube is the maximum cement content that we need to use. Here, I wish to say one thing. It is not that by adding more and more cement, you get strength. You get with lesser amount of cement also. Water cement ratio in the numerator and cement in the denominator. It doesn't mean that water numerator should be less, denominator should be more. Numerator can be less, denominator also can be less. You can achieve maximum strength. For example, even with 360 kgs of cement, 360 to 370 kgs of cement, it is possible to achieve a strength of M40 concrete, MPa compressive strength concrete. It is possible to achieve. we need to use super plasticizers, because when you reduce water ratio to achieve higher workability, you need to use super plasticizer. And the use of mineral admixtures like fly ash or GGBS is also essential. They also improve the workability of concrete. But there is always a limit as per IRC. You can use only about 20 to 25% of fly ash in cement. The last one is about fibers, the use of fibers. Use of fibers will help us in reducing crack. Crack control will be much better if we make use of fibers. Not necessary that we should use steel fibers. Even polypropylene fibers or polyester fibers are good enough to achieve crack resistance. Now let us directly come to the distress part on the concrete road. What are the types of distress that we see? These distress can be classified as structural distress and functional distress. Now, if concrete has a structural problem, definitely it is a very serious issue. If it has only a functional problem, then corrections are definitely possible. We need to look at the failures, determine whether it is a structural failure or a functional failure. Now let us go through the different types of distress and their causes. First, let us look at cracks. Cracks, we can have transverse cracking, longitudinal cracking, we can have corner cracks, we can have durability or decracking. There can be certain joint defects, joint seal damage or spalling of concrete. There can be some minor surface defects, map cracking or shrinkage cracking, and scaling, polished aggregates, and pop-outs. Let us try to understand what these types of distresses are. Now, longitudinal cracking in recent times in a lot of our highways, we are seeing this longitudinal cracking. Indore bypass is one example. In fact, when we were doing our white topping work in Kharagpur, we noticed this on the national highway NH60. Longitudinal cracks very close to the shoulders. This was observed, and the length of this crack goes into 1.5 kilometers. Longitudinal cracks, they continue to be there. Now, yeah, this is yet another photograph of that. Now, this happens mainly because cracks are supposed to occur below where the grooves. Wherever we are cutting grooves, cracks are supposed to occur just below that. That is the reason why these grooves are cut. Now, in these locations, when a core was taken at the grooves, you can see here below the grooves there is no crack, which means concrete is cracking somewhere else. It is not cracking where we want concrete to crack, that is below the grooves. It is cracking elsewhere. Reasons for this could be many, and one of the reasons is that because of the shoulder, because of the widened shoulders, the slab action, it will not be in the longitudinal direction, but it will be in the transverse direction. Therefore, the length across the longer. And second reason is that the shoulders do not have so much of support like the main line. The shoulders have below them the subgrade and subbase, which are not as strong as the main line, main road subbase or subgrade. Therefore, there is a differential thing. This also contributes to the longitudinal cracking. Sometimes we may have cracks something like this. These are not longitudinal cracks. These are vibratory trails, small cracks which are occurring at the surface. These are not longitudinal cracks which I showed earlier. These are vibratory cracks. This happens because the vibrators that we use in the slip form paver or in the fixed form paver, if we have mechanical vibrators, and the speed with which the frequency with which the vibrators operate, that determines or that causes this kind of cracks. Normally, frequency of the vibrator should be around 5,000 to 8,000 vibrations per minute. That should be the vibration. Now, if the vibrations are too high, if the vibrations are of the order of 10,000 to 12,000 vibrations per minute, then it will result in this kind of cracks. It causes non-uniform dispersion of aggregates. There's too much of vibration, and aggregates and cement paste, they get segregated, and therefore that leads to this kind of vibratory cracks. Therefore, we must take precaution when doing concreting. We must ensure that the vibrations of the vibrators, they are within the specified range of 5,000 to 8,000 vibrations per minute. Now let us consider the other types of distresses. Let us take one after the other. The surface defects. Now this is called as map crack. There is no pattern to this. This is called map cracking or plastic shrinkage cracking. Whenever concrete is laid, which has a very high dosage of mixtures, whenever the day temperature is quite high, you will see these surface cracks. What happens is, because water cement ratio is less, the water that is there at the surface, it evaporates very fast, and that makes the surface dry, and that results in this surface cracks or map cracking or this plastic shrinkage cracks. Now, how do we avoid this? The best way to avoid plastic shrinkage is to do night concreting rather than day concreting. During night, the concreting, if it is done, it will be always better. The temperature will be quite cool. Now, so we cannot do it at the night and we have to do concreting at the day. What we need to do is immediately after concreting, we must cover the entire road surface with plastic sheets. Now, you cover it with plastic sheets, water from the surface will not evaporate. Another way of doing that is by spraying curing compounds. By spraying curing compounds, you can overcome this problem. There are wax-based curing compounds. You spray it on the road, it will create a wax layer, a very thin wax layer, which will not allow evaporation of water. Therefore, plastic shrinkage cracks can be avoided. It is just in case of roads, even in case of concrete roofs that you cast your house. Once the roofing is done, if you spray curing compounds, if you cover it with plastic sheets, you can always avoid these plastic shrinkage cracks. Now, this is the plastic shrinkage crack that you are seeing. Now, sometimes what may also happen is the scale. Scaling means removal of the finer surface from the top surface. The cement paste gets eroded and aggregates get exposed. This is called as scaling. If there are too much of fines in concrete, that means if the cementitious material content is very high and there is a non-uniform vibration, that leads to this scaling. How to correct it, we will come to that later. Now, sometimes if the top surface, the finer materials are all removed, it will expose the coarse aggregates. And vehicles move on the coarse aggregates, they get polished, and therefore you see what is called polished surface on concrete roads. Now, this is also one type of thing that you will observe on concrete roads. Now, you can see here, in one part, there is no polished aggregates. On the other part of the photograph, you are finding polished aggregates. This will happen because ineffective curing before ponding or high water cement ratio. Therefore, here what has happened is one lot of concrete has got a good mix, and the other lot, the next lot was not very in terms of water cement ratio, and curing was also not efficient. Therefore, you are seeing two different types of behavior on the same road. Now, this pop-outs like this happens if there is no proper quality control, or in other words, there is some organic matter on the surface when you are concreting. Now, once concrete hardens, and this organic matter goes off, it leaves a pop out like this. Now, these kind of pop outs happen because when concrete is still fresh and not set, still unset concrete, if either dogs walk this or human beings walk on the road, it will leave footprints. This is something very, very unfortunate. You can understand if dogs cross the road, you cannot control all the dogs, it is all right. If we cannot control human beings, persons crossing the road when concrete is soft, that is a very unfortunate thing. It requires a lot of time and effort as money to correct these things. Therefore, this is a typical pop-out. Now let us come to the how to prevent this and what is the treatment in case cracks are there. Now, cracks in concrete can be classified under three heads. One is concrete in the fresh state. That means concrete is still fresh and green. It is still soft. The second case is in the plastic state. That means concrete has set, but it has not hardened. That means within about the first 24 hours, concrete set, but it has not hardened. It has started picking up its strength. And the third are the cracks that happen in the hardened stage of concrete. That is after 1 week, weeks, or after 1 month, 2 months, the cracks that are appearing. Now, if you look at the fresh state, as I have shown examples earlier, cracks may come because of operational reasons, because of vibrations of the paver machine. It can be mix related. Maybe it is not a proper mix, uniform mix or a cohesive mix. It will happen. It will also happen because of loose edges. Whereas in case of plastic state crack, mainly it is the thermal shrinkage or the plastic shrinkage cracks that you observe. Whereas in the hard state, when concrete hardens, when high strength concrete is used, it is slightly brittle, and therefore when it hardens, it starts shrinking, and because of this internal stresses, some cracks would appear. Depending on what type of crack it is, we have to analyze that and then think of what is the solution for this. Now let us look at the operational cracks and the mix related cracks. Now we are talking of cracks in the fresh state. That means concrete is still fresh. We can make certain modifications then and there itself. We have to wait for concrete to set and harden. Later on, it will become slightly difficult to correct it. When it is still in fresh state, we should make necessary correction to treat cracks in time. Now, if these can be to the paver machine, texture machine, or it can be manual intervention. That means variation is slump going either higher or lower, and it may be because of the loose edges, particularly in case of slump pavers. Cracks that are developed parallel to the edge. These are the loose edges in case of slip form paver. Therefore, in all these cases, we must make the correction then and there itself, not delay that. Yeah, here you are seeing some photographs to see the effect of poor slump control and poor base compaction slip form pavers. Now the edges, in some cases, you are seeing it is breaking. Now these are the cracks like this, which are happening when concrete is still in the fresh state. We can always do refinishing. That means with slight cement or cement mortar with water, make that slurry, cement slurry or mortar slurry you make, and you refinish the entire surface, the trowel, you are correcting these cracks. These cracks would get corrected because concrete is still in the fresh stage. Now, for cracks in fresh concrete, the treatment is, number one, identify the reasons for the cracks to appear and take the preventive measures. And for the cracks that are already appearing when the concrete is still green, all you have to do is retrowel the concrete with a little thick cement slurry or a cream vibrated concrete, and make the texturing. These texturing machines should be ready and available, and texturing should be done transverse texturing or longitudinal texturing, it should be done as early as possible. And using of curing compound, it should be done immediately after texturing. That means laying of concrete, finishing it, texturing it, and immediately after that, apply the curing compound. If you have automated engines, they will take care of this particular thing. Now, what are the repair techniques? In case all these cracks or pop-outs are there, what are the repair techniques you have? There are a lot of materials, repair materials that are available today. You have polymer mortar, polymer concrete, liquid epoxies, epoxy mortars, normal cement concrete reinforced with fibers, fiber reinforced concrete, bits mixes and sealants. These are all the things. Now, this is what I was telling you about plastic shrinkage cracks. It with a plastic sheet, that is the best precaution that you can think of. In the other photograph, you are able to see a small photograph where cure compounds are sprayed onto the road so that it forms a layer and prevents cracking. Now, in case shrinkage cracks appear, the procedure is simple. Clean the cracks with wire brush and pour low viscosity epoxy resins. They are available. Low viscosity epoxy resins are available in the market, and pour them into the crack and sprinkle fine sand over this sealed crack for skid resistance. That will take care of this plastic shrinkage cracks. You can see here in the first photograph, the cleaned cracks are with the wire brush, and then pour epoxy resin, low viscosity epoxy resin into the crack. So that the sand that is sprinkled over this cracks for skid resistance, and the road is finished. There was one hand raised. There was a question, I believe. Professor Kavita, if you have the question, you can ask right now, or we can take it later also. It is yours.
I think we'll take it later, sir.
Okay. Now, the road is finished and you're able to see the sealed cracks. Now, if the cracks are wider, then what is done is if the cracks are, let us say, half an inch, then we make it manually. We make it about 3/4 or 1 inch wide cracks so that this material repair epoxies can be poured into it. And you can see it is being finished. You have these grouts that are available very widely. They are available. These grouts are applied and the cracks are all finished. The only thing, once it is finished, you may be seeing these finished patches. They may be visible, but functionally that will not cause any problem. We can go ahead. Now, sometimes what happens is the texturing that we do on concrete roads over a period of time, after 5 years or 6 years, it will become smoother. This texturing, it just fades away after some time. Therefore, after that, to ensure that vehicles don't skid, there are diamond grinding machines that are available. These are the diamond grinding machines. Using these diamond grinding machines, we can always regroove the concrete surface so that this is a part of maintenance, I would say. It is not a repair, but a maintenance schedule. It is included in the maintenance schedule so that regrooving or retexturing can be done. Yeah, this is how regrooving is done for a road. Sealing a crack with the sealant. The crack, if it is less than half an inch width, it is actually widened up to about 1 inch, and then sealants are applied, and the debonded strip that is also placed. Now, if there is a spalling of concrete, that is in case of a pop-out, you are able to see that in the plan and elevation. You must make sure that it is a rectangular surface in plan as well as in elevation. Otherwise, whatever the grouts that you apply will not stick to the roads. Therefore, what you should do is both in the plan as well as in the elevation, you make it rectangular, and the depth of this should be at least equal to 1 inch or 25 mm. and finish it with epoxy, which can get a strength of about 40 to 45 MPa within 24 hours, not 28 days. They can get a strength of 45 MPa with 20 hours or 24 hours. So we can use that so that the road can be open to traffic very fast. Now, this is where this is one case where the deteriorated portion is being removed, and yes, this is how it is made rectangular in plan as well as in elevation, and it is finished with the cement grout or the concrete grout, and so that the road is restored to its original thing. Yeah, this is what is called as a thin bonded repair. If there are pop-outs like this, make it into rectangular parts and then finish it with that. Yes, this is another one, repairing of a pop-out. There are a lot of materials. One of them, of course, is the Ultratex Power Grout, which gets a strength of about 40 MPa in 24 hours. There are several such grouts available in the market, and this has been quite popular in Mumbai for several roads. This has been used as a solution. Yeah, the advantage with this grout is that it is an excellent material for repairing roads, airstrips, and floors, and for crack filling, repairs to bridges and bridge decks also. Very fast, it can be open to traffic. Another method of treatment whenever there are cracks is by what is called as stitching. Now, if it is a full depth crack like this, what is done is, as you can see there, at an angle of 25 to 30 degrees, we make a drill hole across the crack like this, and within the drill hole, you put a steel rod, maybe about 20 diameter rods you put, and then grout the joints. That will ensure that there are no cracks. There will be no problem to this. At regular interval, if the X are small, even 12 rods are good enough, which are used for tie bars. The same tie bar rods, 1 foot length, can be used at 50 millimeter center to center. And if it is very wide cracks or a heavy road, then you can go for 32 thing. So for longitudinal joints, across the longitude joints, these bars are placed, and this is what is called as stitching. Now, after stitching is done, this is how it looks like. Maybe it doesn't look so good. You can see here, you may be able to see the stitch marks there, but that is all right, though it may not give a very aesthetic look. The purpose is served. The concrete road is restored back to its original shape and strength. Now, this is how the stitched slab looks like. Another tech is called as, wherever there are cracks, another technique is what is called as stapling. Staplers, you know how we do staplers on papers when you are joining papers, very similar thing. And in this case, the steel pins, these steel pins are used, 16 rods bent at both sides. They are filled into the groove, and epoxies are filled after this. This groove is sealed after that. This is called as stapling at a regular 500 interval are placed. You can see here, these staplers are placed below the thing, and at the top, you finish it with the epoxy grout. So this is how it looks once it is finished. This is how it looks, and there will be no further cracking of concrete once you do this. All of us know about the dowel bars which are placed on concrete road. As per IRC, dowel bars are required to be placed if the thickness of concrete road is more than 200 Now, the question is, there is another question whether dowel bars are required or not. Anyway, let us not debate that, because IRC has said 200 beyond 200 more than 200 you have to use dowel bars. Now, the question is, properly placed dowel bars versus improperly placed dowel bars. Now here you are seeing in plan as well as in elevation, dowel bars placed are proper. Now I would say improperly placed dowel bars, as you can see in the photograph, improperly placed misaligned dowel bars are worse than not providing dowel bars. Or in other words, I would say the first or the best way of construction of roads is to provide dowel bars properly. If we cannot provide dowel bars properly, it is better not to provide dowel bars. Otherwise, it will create a bigger damage than having improper dowel bars. Now, if the concrete surface has fully deteriorated, we can go in for full depth repair. That means cut out the concrete from the surface and make it a rectangular opening. And on both sides of this, provide dowel bars as per design, as you are seeing there, and provide proper chairs for putting concrete this whole thing. Say you can see here, full depth cutting and removal of concrete. That is what is being done. And after the drilling holes for inserting the dowels, and once you do that pressure clean this holes using pressured air, clean that and dowel bars, insert dowel bars and seal them, and then pour concrete. Now dowel bars are being inserted and sheathing is provided, and on that concrete is poured, compaction of concrete, so that the entire patch is finished. This is how the whole thing is finished. Then creating texturing, curing compound spraying, and the whole thing is finished. Now that is called as entire panel. If you want to remove and redo the whole panel, then that is the best way to do. Therefore, whatever be the type of distress in concrete, always remedial measures are always available, depending on whether you see the distress in the fresh state of concrete or in the hardened state of concrete. Now, going ahead, another way to ensure that distress-free concrete is obtained is by going in for precast concrete construction. Precast concrete slabs, they are made in the factory, they are brought to the site, they are placed one by the side of the other in the same way as we have as we build our flyovers. In the same way, precast panels are laid, and these precast panels they are laid even before the road is closed for traffic, so that this can be done in 1 or 2 days time. You don't have to spend a lot of time for making this concrete road, and the quality of concrete will be good. Cracks or pop-outs will not come. It will be an excellent road. Now, this road, for the first time in US, it was done in 24 hours time using precast concrete panel. There are different countries which are doing that. Singapore experience is slightly different. Say precast concrete pavement, they use what is known as a coupler for joining the concrete panels. They join them using the couplers, and within the couplers, they put grouts and they join the concrete panels like this. This is the Singapore doing this, and you are able to see that old man, Dr. Alfred E. He had come to India also, and he is an expert in precast concrete pavements, and he had come to India also. He wanted precast concrete pavement to be constructed in India. That was 10 years back. We did not do that at that time, but then now we have done in Nagpur. There is the first precast concrete road in the entire country is built in Nagpur. About 400 meters of road has been built in Nagpur. Excellent quality. These panels were cast in the factory. They were brought to the site and they were aligned, and the joints were grouted, and the entire thing was completed in few days time. Very, very congested junction. You're able to make this, and the precasting unit. And this is the best example, Professor Matthew. This is a best example for industry institution interaction. The design was done by VNIT Nagpur, and it was executed by a precast contractor, and the concrete was made by Ultratech. This was an excellent thing. This is a topic of research also, and now this is getting into IRC code. Indian Roads Congress has formed a code committee for doing this, and the code is also coming, but this road is done. But then the next road is coming up probably in Bangalore. The Bangalore Corporation has identified a road for making this precast road, and maybe the engineers in Kerala, Tamil Nadu, and Karnataka, the students should make it an opportunity to visit this site during construction. Sometimes people say, is a precast road, how does it compare? Definitely, it compares much better. As you can see, the rigid pavement thickness reduces from 300 mm to 200 mm because it is precast, cast in the factory. You require lesser thickness. Therefore, comparison of cost also is there. Steel diameter dowel bars instead of 32 mm, you can use 25 mm. Curing is not required at site. These are all certain advantages. And cost is also the same because the concrete thickness is less in case of precast. Therefore, normal concrete road, whatever is the cost, same cost precast road also can be done. Therefore, friends, the concluding remarks of this thing is that concrete is more than a structural product. It is a very, very versatile product. It has incredible design versatility, flexibility, and it bestows environmental benefits, economic benefits, and social and quality life benefits. And I'm fond of saying this, concrete is a democratic material because anyone and everyone can make concrete roads. It endures and it is tolerant like democracy. Democracy endures, concrete also endures. Therefore, we can call concrete as a democratic material. But like democracy, democracy is most used in our country. Sometimes it is missed, sometimes it is abused. Very similarly, concrete is also made very well in most of the cases. Sometimes we misuse concrete, sometimes we abuse concrete. Then we will see all kinds of distresses and collapse of the structure also. But concrete, I would like to quote Dr. Kadiali, who is my guru, who used to say that concrete is an unforgiving material. It shows up, it tells you what are the distress it has, and if you still don't attend, if there is fever, it shows up. You are supposed to give medicine. If you don't give medicine for fever, then you will see bigger disease. Therefore, keeping that in, it is our responsibility to make concrete a distress-free construction. Whether it house or a road, distress-free construction is always the need of the hour. With this, I hand it over back to the organizers, and I thank you all for your patience. And now I'm open to questions. Any questions from the audience? I'm open.
Thank you, Dr. Ramachandra. Good. And as I too have seen that Nagpur panels when I visited even that NH section also I've seen that the precast this one it was there in the NIT campus also. I think in NIT campus also I've seen that one.
Correct. They started from NIT campus.
Yes, myself and Veeravan sir, we together visited that during the IRC session at NIT Nagpur.
Yeah. I think there is one hand raised. My other good friend, Lokesh.
Lokesh is there. Lokesh, good evening. Welcome.
Lokesh, Professor Matthew, I am very proud to say Lokesh was my student when I was teaching. But now he has grown into a great expert. Nice to have you, Lokesh.
Sir, good evening, sir. Good evening, Professor.
Yeah,
Sir,
good evening.
Can you just throw some light on grinding of concrete, sir? Pavements.
Grinding, that is retexturing?
Yeah, exactly. Retexturing. Because most of the time, what we are seeing that over a period of time, due to the movement, the texturing as well as the skid resistance is reducing in concrete pavements.
Correct.
Can you please throw some light on that, sir? Thank you.
Yeah. There are today these grinding machines that are available. Because unlike the first time when you cut the grooves, it is a fresh concrete and therefore it is easier to cut. Now, after 4 years or 5 years, you are cutting a hardened concrete, MT or M45 concrete, therefore it is a bit difficult. Therefore, we need to use this diamond groove cutting machines, which are available. They are available on hire also. So they are available, and with this diamond groove cutting machines, definitely at predetermined, predetermined distances or spans, grooves can be. This has been done in several highways where the concrete surface became quite smooth. Yeah.
Thank you.
Kavita is here.
Kavita, good evening.
Good evening, sir. Thank you. That was a very excellent presentation, sir. I could learn a lot of things on how to treat the various distresses in concrete. Sir, my question was, please throw some light on these tied concrete shoulder and then the widened concrete, which has been introduced now in IRC 58. So how does it reduce the thickness? To what extent does it reduce the thickness in case it reduces?
Now, these tied shoulders may not, I mean, the slides I showed where longitudinal cracking there.
Sir?
I mean, is your question related to the slides I showed where longitudinal cracking was observed?
No, sir. This is basically on the design part where IRC 58 mentions
Okay.
about options of design.
Yeah. See, tied shoulders, the advantage is that when it's tied to the main carriageway, the possibility of having cracks on the tied shoulders is very much reduced. Now, on shoulders, the problem always is that the quality of sub-base or the subgrade may not be as good as the main line. Lokesh also has come up with, we have seen that in many of these, not only highways, but also in city roads, we have seen this, wherever you have the extended portion of the roads, whether it is concrete roads or even in Wapping, where the bitumen roads were there, the extended parts of the roads, they were earlier footpaths. The footpath converted to roads by widening. Therefore, it does not have the layers of the road foundation that the main roadway or the main stress. Therefore, the best way for that is always to build at the subbase and then go for the shoulder. That is always better, so that the quality of the shoulders is not impacted, or we don't see cracks on the shoulders. Lokesh, would you like to add anything on this?
Yeah, exactly. That is true, sir. One point I just wanted to add over here is this is basically applicable for the new pavement design, which is done as per IRC 58/2015. What exactly happens is, as we all know, sir, from the edge, we are placing the first dowel bar at a distance of 150 meter for transferring of the load. It is also assumed that with the addition of another 1 meter or 1.5 meter as a paved shoulder, which has the same this thing, the dispersion of the load get deferred, due to which the overall thickness of the pavement get reduces. Generally, for a tune of around 2 centimeter, there will be reduction, sir. Kavita, madam.
Okay.
Yeah, about
Thank
20
you.
mm.
Thank you, sir.
Yeah.
Thank you, Lokesh, sir.
Thank you, madam. Thank you, sir. It was nice, sir. We never miss Ramachandra's presentation wherever we are.
Any other questions? Jimmy, you would like to ask some questions? Galot? Dr. Galot? Yeah.
Sir. Sir. Good afternoon, sir.
Yeah, good afternoon, Jamie.
Sir, when we are constructing rigid pavements and when the conduit is laid, when we should start the curing actually?
Yeah. There are two things, Jimmy, I want to say. You should start curing, or the spraying of curing compound should be immediately after texturing. Now, concreting is done, compaction is done, and if you are doing the texturing, the texturing is done, and immediately after that, either use plastic sheets or curing compounds and close the thing so that immediate evaporation does not happen. But then the normal thing can start after 24 hours. This will be effective for 24 hours. And within 24 hours, if you do this, either plastic sheets or curing compounds, it will ensure that plastic cage cracks don't happen. And within 24 hours, you can organize the normal curing like bonding with water. So, and that should continue. That should continue for at about 1 week or 1 week. Curing is essential.
Sir, as we discussed this, the human footprints and it will affect this concrete pavements. So,
Correct.
What is the method, the best method, sir, for curing?
For this pop-outs, you are saying?
Next,
Said about
curing.
pop-outs. Okay. Yeah, now I understand. That is why, see, what is done is just behind this slip pavers, if I understood your question properly, just behind this slip form pavers, as slip form pavers moved, they make a kind of a stand so that, people don't walk on it even for laying the curing compound. People don't walk. I mean, I think one or two photographs I had, I think that was missing in this. Maybe because of the number of slides were more, I think I had removed that. What they do is they make a kind of a stand just behind this thing, and on the stand, people can walk. They are walking a stand. They are not walking on the concrete road. So standing there, they would, spread these plastic sheets, or they spray this curing compounds. Nobody should walk. Even for curing compound spraying, they should not walk on the concrete road. And after 24 hours, of course, it would have been some amount of this initial setting would be over. And then you should spread these gunny bags and things like that, and ponding should start. In 24 hours, generally, if you are using M40, M45 of concrete, in 24 hours, concrete would have a strength of 15 MPa. So M15 concrete is good if people walk on that.
Okay, sir. Thank you so much.
Dr. Suresh, you would like to ask any question? Dr. Galot?
Sir, good evening, sir.
Yeah.
Good evening, sir.
Sir, your presentation was very good.
Suresh Kumar, you just wait, and I think Dr. Suresh
Okay.
letting come.
Another Suresh, is it?
Yeah, but two Suresh are there. Okay, both are Suresh Kumar.
Okay, sir. Okay.
Yeah, Suresh, see.
Sir, this precast panel, what would be the normal size?
It will be again 3.5 by 4.5, and the thickness would be about 200 mm. 20 centimeters.
3.5 meter.
Yeah, that is the thickness generally. It depends on your design. It is not that we should have the same standard everywhere, but that is one option. Dr. Suresh Kumar?
Sir, it was a very nice presentation, particularly on the distresses that you have mentioned. Only one thing, sir. Generally, people get confused between fresh concrete, that is newly designed concrete pavement, and rehabilitation of a concrete pavement. They are completely two different issues. It should not be looked in the same way. In case of you can say rehabilitation of a concrete pavement. Sir, is there any specific code for that?
Yeah, SP83, IRC SP83 is precisely for that. It revised in the year 2018. Repair, rehabilitation, retrofitting of concrete pavements. That is SP83. It is available. Recently, it was revised. I was fortunate to be a part of that revision group, and that is quite a exhaustive code. IRC code is available.
Okay, sir. Thank you, sir. It was a nice presentation.
Thank you, Dr. Suresh.
Yes, sir.
Any other questions? Wilson?
Yeah.
Anybody from NATPAC? Sanjay, if there no further questions, probably.
Yes, sir. Yeah, we don't have any more questions or chats in the chat box also. So thank you, sir. So that ends a very nice presentation. So we are having one more good presentation as part of this lecture series, which commenced in the 23rd of this May as part of the Golden Jubilee celebrations of science and technology in Kerala. We had 5 eminent experts talking on various prospects of transportation, starting with Dr. Kunjuri Isaac, starting on with the urbanization prospects of Kerala, followed by Dr. Vijay Kumar on publication of journals. And then we had Dr. Velmurugan, the chief scientist of CRRA, talking on utilizing artificial intelligence on traffic engineering aspects, taking Nagpur as a case study, in which one study is being carried out by CRRA. In the study, we had talked by Sri Suresh Kumar sir of the chief engineer of KUL, who is present here today also, who has been a regular participant of this particular lecture series. And finally, today we are having Ramachandra sir to deliver on this distress-free pavement. And of course, today's topic is of very much relevance, as we all know, because even to me, when I still remember one of the questions which was asked to me during my interview in NATPAC in 2005 regarding the utilization of rigid pavement for this one and comparing it with a flexible pavement. So it was some sort of an enigma to most of the transportation engineers, and thanks to the efforts by most of the experts, like you said earlier, that rigid pavement construction is being progressing in India, and also, of course, we also are having some roads being constructed in this as a rigid pavement in Kerala also. So thank you, sir, for a very nice presentation for the particular topic, starting from the history of concrete pavement, talking on the various diseases that can happen, and how very small solutions can make these pavements as distress-free. So on behalf of NATPAC and all the scientists and the KSCSTE who has been supporting our endeavors in this effort, I thank sir for this particular lecture. And I thank all the other experts who have been talking, who have been delivering lectures starting from Monday to Friday, and other dignitaries and researchers, scientists, and faculties who have been joining us for this event through online modes from various institutes. Thank you, one and all, for making this lecture series a grand success.
Thank you.
Thank you, Ramendra sir.
Thank you. Thank you.
Any chance when you are coming to Kerala, like listen, probably we can have more discussions. Kerala, we would like to introduce that precast, the concrete,
Yes.
like sections, like we have seen that one at Bangalore and all. So in along the coastal area also, we would like to have this. We tried the cement concrete pavement. So
that is the reason. That is the reason why I asked you where you are. Maybe in my next visit to Trivandrum, I'll catch up with you.
Yeah, please. You are welcome, sir.
Thank you.
Yeah, thank you, Dr. Kavita, and like our this one, Suresh and all. Okay, thank you all.
Thank you.
Logesh also, I think he left. Logesh also left. Good.